Hello and welcome back to another episode of the Natural Number Game with Lean. I can't believe it, we're on to our second to last world, the Advanced Multiplication world. It's been a fun journey so far. I've definitely learned a lot about both Lean, Lean 4, and some cool math stuff. Let's jump right into this world. Import mynat, open mynat. I have a fresh file for the advanced multiplication world. And let's see. Level 1, mul pause. Welcome to the advanced multiplication world. Before attempting this world, you should have completed 7 other worlds, including multiplication world and advanced addition world. I think I actually did 8 worlds because I also did the power world. Recall that if b colon mynat is a hypothesis, you can do cases and so on and so forth. Cases is like a weaker version of induction. You don't get an inductive hypothesis. Makes sense? And it talks about some tricks if we need to use them. Cool. So, theorem. The product of two non-zero natural numbers is non-zero. That's very helpful. That shows that, there's no zero dividers. Is that what it is? Yeah, no zero dividers in our ring of natural numbers, I believe. Or that mynat. Oops, here this. I think it also might mean that we have an ideal ring, I believe. I'm not 100% sure. I need to brush up on my abstract algebra. Not equal to 0 implies, you can use the nice Unicode arrow, implies b not equal 0 implies a times b not equal to 0. Bye. Okay, let's get this all. It's a little hard to see here, so I'll move this down here. Bye. Sorry. Okay. So what do we have here? I guess we can intro not equal a, not equal b. Okay, we have something. A is not equal to 0. B is not equal to 0. Now what? Let's probably want to look at the advanced multiplication world and the multiplication world to get some tips. Okay, so we had n not equal to successor. Add left 0, successor stuff. Okay, nothing here seems to be 0 doesn't equal successor of a. Okay. Nothing here is super helpful. Let's look at our multiplication world. We'll probably want to, if I had to guess, import mynat.multiplication. Tons of useful stuff there that we'll probably want to use. Okay, let's look at multiplication world. Mul 0, mul successor, 0 mul 1, mul add. Okay, one idea I have is maybe we can turn one of these into the fact that it doesn't equal 0. We also know that since a doesn't equal 0 and b doesn't equal 0, then a equals successor of something, b equals successor of something. We can have successors here, we can have an addition, and then we could have non-zero addition means it doesn't equal 0. That's my one idea. Oops. Not too sure if that'll work out, but let's see if we can try to do that. Okay. So in my advanced addition world, 0 doesn't equal successor of a. So can we rewrite this successor or something? Do we have access? Oh, I need to also import mynat.advanced addition world Yeah, this will be kind of hard, so I'll take some time with this and try to figure out how I can do this. Okay. Can I do this? What happens here? We want this to rewrite fail equality or if and only if proof. Expected. Okay, that's fair. I guess I kind of want to like have two inequalities lead to an inequality. Oh, maybe I can kind of based off the hint here that we can just kind of have the cases and we can look at all four cases of A and B because they're natural numbers, and then they're not zero because we have the hypothesis. So can we do like cases A zero, successor of A prime. Sorry. That's not how we do that. Oh, maybe with? Yeah, okay. Well, here we have NEA is 0 doesn't equal to 0. So can we do, oops. This seems promising. Here we have 0 does not equal 0, and that is absurd. Can we do ruffle? No. Contradiction. Cool. What does contradiction do? Contradiction closes the main goal if the hypotheses are trivially contradictory. Yeah. I think we can also just do false.elim NEA. Oops. Give me a by here. Oops. False.elim. How did I do that before? In the advanced addition world. Exact. Oh, we need an exact. Exact. Maybe there's a let f equal NEA. Sorry. I want to get to the bottom of this. NEA dot irreflexive? What is this? Ah, okay, there we go. So there's this irreflexive thing on things that are not equal, which that if we have two of the same things, that's just false. Okay, so instead of just doing contradiction, which is a pretty powerful thing that just looks for a contradictory hypothesis, we can do exact false.elim not equal a irreflexive. Great, and now over here we have a very simple thing. Cases B with, I'll move this down here, oops, cases B with 0, exact false dot elim not neb dot irrefl, successor B prime. Okay. Now we have successor of A prime times successor of B prime doesn't equal 0. Okay, this definitely feels like progress. And then we have NEA successor of A does not equal 0. We have NEB successor of B prime doesn't equal 0. But A prime could be 0 and B prime could be 0, which is fine. So we know that successor of something can't equal 0, so let's see if we can pull the successor stuff out. How do we do that? Probably some things. So can I do any, what else is present on inequality? So when we had this, we had let f equal NEA dot elim dot, what is NEA dot symmetrical? Oh, so let's switch it. NEA dot elim. Okay, A does not equal B implies A. If we get A doesn't equal B and A equals B, we get false. Okay. So now this whole thing just needs a, if I have a 0 equals 0, I get a false. That makes sense. Because the NE dot elim needs both of those. Cool. So I think in the end I'll apply something from the advanced addition world that says successor of A does not equal 0, so I need to have just this be successor of something. And then we can deal with successors and addition with this successor mole. Okay, let's apply successor mole. Rewrite successor mole. So that turns into A times successor of B plus successor of B. A could be 0. A prime could be 0. Can I just let A prime? Or I guess I can just pull the successor out. So now I want to go to my just addition world. Where's my addition world? Addition world. Do I pull a successor out? Successor add. Alright. Okay, I want to use add com first and then successor add. Add commutative. Successor add. And now I can like, what is this? Successor not equal 0. Bada bing, bada boom. Nice. Okay, and this took in just this whole expression. This is just able to placeholder it, and I solved mole positive, which is a very useful theorem. Great. Took a nice little tea break because tea goes really well with math and programming. Let's move on to the next level. Oh, okay, this is actually a helpful trick. So this says that if your goal is something doesn't equal something, if I do intro H, I get H as my, like the equality as the hypothesis and false as the goal. That's pretty helpful. Okay, but we didn't need that this time around. Let's move on to level 2. Level 2 equals 0 or equals 0 of mole equals 0. Ah, nice. Okay. This kind of shows, is kind of, what is it the contrapositive? Yeah, this is the contrapositive of this statement. Can I just use my contrapositive from before on this? We'll see. Theorem equals 0 or equal 0 of mole equals 0. What a long name. Okay, we have A, B, natural numbers. And then we have h a times b equals 0. We want to prove a equals 0 or b equals 0. We define that by, okay, let's just try this. Let f full contrapositive of mole pos. Huh? Oh, where do I have full contrapositive? That's in my advanced proposition world. Okay, so I need to import that. Import my nat.advanced proposition world. Okay, what is f now? Why do we have sorries in here? Oh, I need to put in AB. AB. Does that work? What's wrong here? For all PQ. Oh. So is mole pos. I need to do mole pos of AB like this. So let's try this. Let F1 be defined by mole pos AB. Okay. F1, I believe, is a proposition. Type or check F1. Huh? Check mole pos. One, two. Is there a type? Is there a print? Oh, I don't want to print that. That's kind of gross. Whatever. Okay. I think F1 should be a proposition, so I do full compositive. F1, what is this one? Okay. F1 has type this, but I expect it to have type prop. Well, that's not quite what we want. Okay, can we do of H? What is H? No, these aren't propositions. Prop dot implies self, implies transitive, implies anything useful here. Implies, we need propositions. Okay, maybe there's a true implies that, false implies true. Yeah, okay, maybe there's a way to do this, but I don't know how to do this with contrapositive, so we will not be doing this with contrapositive, unfortunately. This has been a cool way to hack this and get us a quick solution, but no success. Okay, well, let's do what we know how to do. Okay, so now our goal is A equals 0 or B equals 0. Let's check out our advanced proposition world to remember how we dealt with that. So when our goal is an OR, we need to do OR.elim. Okay. because our goal here is an OR, so we need to do OR.elim in the end. Okay. Not Q, not P. Okay. So we'll have something exact OR.elim. And what are the three things OR? Oh, it just takes two things. Okay. Oh, and it takes if A or B and both A or B imply proposition C, then C is true. So let's look at this proof again. Okay, so here we have OR symmetric. So intro PQ. And then our goal is, okay, OR.elim. P implies PQ. A or B. A side, B side. Okay. Implies C. Oh, here we just get C with OR.elim. Is that even, wait. Here is P or Q. I think we just need to have one side of it be true. Okay. I don't think we actually need both sides. We just need, we just need OR.elim takes an OR statement. Exact. Okay, so hypothesis A times B equals 0. Well, that means either A equals 0 or B equals 0. Oh, well, that's what we're trying to do. I guess we can try cases A again with 0, successor A prime. Sorry. Okay. Well, if A is 0, well then mul 0 rewrite mul 0 at H. That'll work. 0 mol. Zero, and then we can have OR dot left side H. Exact. Okay. Now successor A. I think we probably want to break it up into cases with B again. With 0, sorry, successor B prime, sorry. Okay, so I think we should do the exact same thing for the 0 case, but we're going to use, oops, oh, it's be mul 0 this time, yeah, mul 0, INR. Okay, now in this case, successor of A equals 0 or successor of B equals 0. Can we intro anything? Intro. No. So we need to, okay. Well, we know that the successor of A doesn't equal 0. Successor of B doesn't equal 0. I think we can just think we just need to use mole position here. Okay, I think what we need to do is like somehow we have A, we have B prime. We don't have A or B anymore? No. I guess B is successor of B prime. Let A equal successor of A prime. Let B equal successor of B prime. Okay. And then can I show that A does not equal 0? Let F be successor not equal 0 of A. Where's F? Oh, A prime. A prime. Rewrite, can I do like A at F or something like that? I'm not sure. Successor of A does not equal 0. Let's see, whatever, like not equal A. Let not equal B. Successor not equal 0 B prime. Okay, let's try to apply mole pos not equal A, not equal B. Successor A prime, successor B prime. Okay, this is promising. Successor A times successor B prime does not equal 0. Hell yeah, okay. Okay, now what do we do? Okay, these A and B aren't helping me yet, so I'm gonna comment them out. Oh, we have H successor A prime times successor B prime equals 0, and we have F successor A prime times successor B prime does not equal 0. So we can do exact, and we have our contra statement from before. FH, can we do this? No, we can't do this. F dot elim H dot elim. Can we do absurd? Okay, we're very, very close. So we have F and we have H. And when we have two things that don't equal 0, or we have two false hypotheses, this should be impossible. I feel like I'm very, very close. Let's see if we can solve this. I think the only things that are important here are F and H and how we kind of combine them to get false. Whew. Let H prime equal H dot this anything? No. Equal dot. Can we? Is there something that I can just give two inequalities, or like an equal and a not equal, to get me true? False dot elim not equal dot. Huh? Oh, it's not equal. No, any dot elim. Oh, any dot elim. Yes. Okay, yeah, that solves it. Any dot elim hf. What's wrong here? Oh, we need the not equal to fh. Whew, this is false. Exact false dot elim any dot elim this. Okay, and I guess that shows you an example of how you can use VS Code to like search different functions and mouse over them to figure out what could be helpful. And then once I saw the type of this, a not equal to b, a equal b, false, I knew I was good. This is exactly what I needed, and this is kind of like our contra from before, but this can take equalities as opposed to propositions. Wow, that's equal 0 or equal 0 of mole equals 0. Solve the contrapositive. I believe it's contrapositive because like implications I think are like ands, and an or becomes an and when you negate it by De Morgan's law. So I think it kind of just like flip and flops. So I believe these are that. Oh, okay. Actually, it does seem like it is so because the next thing is the next level is mole equals 0 if and only if. Great. I think I'm gonna end the video here though because it's already quite long. Next time we'll continue and hopefully finish the advanced multiplication world, starting off with generalizing this into an if and only if statement. Thanks so much for watching.